motion of rigid body. What's happened to the rigid bodies? Rigid body is like the body doesn't have elasticity. Okay, rigid body has 6 degrees of freedom, 3 parallel direction and 3 rotational motion. That means it can move x, y, z direction, and also it may rotate without fulcrum. It's rotate around the center of gravity, and it's 3 different way to rotate. So when you have a string here, hang this part, and you have a disc here, center of gravity pretty much here. So this arms is going to generate a torque by gravity and string tensions. So this torque is going to make 2 motions, parallel motion. The center of gravity move down and move this direction, and this whole thing spin. It doesn't move like here, it's rather move like this way. So that means it's spinning around the fulcrum. Okay, so make the both parallel movement and rotational movement when it's not spinning because of this. Okay, we show you by video. Okay, little experiment about gyroscope. The one side is hanged by a string and other side is nothing. So when you put it in a horizontal position and release, it drop. When it is spinning, disc is spinning this direction, okay, then what's happened is this has an angular momentum. This angular momentum is a spinning speed, omega, and moment of this disc. Okay, it's going to give you angular momentum. So we have a vector here already, and this torque is spinning this way. If you look at from above, you see this direction means the vector is going into the paper. Okay, so which is this one. Okay, so this is going to be the new angular acceleration. New angular acceleration applied to the existing momentum, so it's moved this way. That means the whole thing is gonna spin slowly by this, generated by. Okay, so in this case there's no parallel movement, it's all rotational movement. The original rotation plus added acceleration for rotation. Okay, so when this rotational axis move, it's called precession. Okay, so I show you this in the video. The vector is the spinning vector plus acceleration vector is going to move whole things around. We're going to give an angular momentum. 1, 2, 3. Okay, here you go. Now it doesn't fall. But it's spinning. So notice that. Spin direction and precession. I'll explain that. Okay. Okay. You see that in the top too. The precession motion on the top is when it's tilted a little, the gravity is going to call the rotational vector together with this tops, depending on which direction it's spinning, either this way or this way, is added up. and what's happened is cause gravity to the gravity causes a precession motion, and when you have a sufficient friction here, then it's correct itself, so it's stand up itself. That's why spin top is stable on the ground while it's spinning, because once it's tilted, this move around. Okay, depending on which one it's I show you in the videos. Precision direction is opposite, depending on which way top is spinning. Okay, one more time. The other way is not easy. You see which way the precision is going? Okay, so that's the motion of rigid body. It's remember 3 freedom of the motion in parallel motion and 3 freedom of motion in the spinning direction. Okay, so anytime gravity acts as a spinning rigid body, it's going to adapt to existing angular momentum. Angular momentum, and this causes the precision. Okay, so that's the physics. We have other videos, please check. Thank you for listening.